Okay, you can follow along with the slides that I've posted on Blackboard. What I'm going to do is I have a set of grades here for students. This is their final grades for a course. And what I need to do is I need to bell those grades because the dean wants to make sure that scores are not impacted by how soft and kind and easy I am in terms of giving grades. So they're a bit worried that my grades are inflated, and they want them brought down to what the college says. This is all fake. What the college or university says that it should be. So first thing I'm going to do is I'm going to calculate my mean and my standard deviation, and I'll use the functions in Excel. So we know the mean is equal to the average, and the average is 79. Oh, that's way too high. Equal to ST dev sample, which we did last week. And there we go. Oh, and the standard deviation is, let's keep that, is 13.6. I'll carry that to two decimal places, and I'll move that out. Oopsie, I don't want that many. Now, so I have a problem. My marks are, because I'm just so kind and generous, and I want to be everybody's friend, means way too high. So I have to change those grades. This is a step-by-step process. So I'm going through this in Excel. You can follow along also on the slides, PowerPoint slides I've posted. Well, step one. Um, so step one, I need to subtract M, and I'll format paint that. That's step one. Okay, so I'll just fill in here. So I'm going to take each score and I'm going to subtract the mean. Make sure I put the dollar signs around the B13 for the mean so that when I drag that function down to repeat it for all 11 students, um, the reference always sticks to B13. Now, when I've done this, I've taken all the scores, subtracted the mean, so I've slid all the scores down a distribution, like slid them down the number line. And I can see what my new mean is. My new mean will be 0, and my standard deviation will remain 13.6. And that's the case. So step 2, divide by the SD. So now what I'm doing is I'm taking each score and I'm going to take what I did in step 1. I'll take the result of that and I'll divide it by the standard deviation, which is 13.6. So I'm going to go to B14 for that. Now, when I've done this, I have a new mean and new standard deviation. And the new mean is 0, and the standard deviation is 1. Okay, that's I want, and this is referred to as a z-score. And a z-score is equal to a value minus a mean all over the all over the standard deviation. So these scores here have a special name, and they're referred to as z-scores. So step 2 creates a z-score, and a z-score is a very special score in statistics, and that special score, when I do this calculation of subtracting the mean and dividing by the standard deviation, if I do that for every score in the distribution, I end up with a new distribution of scores which are referred to as z-scores. And that new distribution, that special score, which is called, now these special scores here, which are called z-scores, that distribution, when I've done this step 1 and step 2 to create the z-scores, it will always have a mean of 0 and a standard deviation of 1. And they're referred to as standardized scores. We're going to see this a number of times throughout the semester and next. Step 3. So I need to multiply by the new standard deviation. And I'll mark these down here. So M new is 65, and SD new is 5. So now I need to take those z-scores and multiply them by the new standard deviation. I need to, I forgot my F4, put the dollar signs. And if I look, I have a new mean and standard deviation. And my new standard deviation is 5. So I've multiplied the z-scores by the new standard deviation of 5. So I've kind of spread the scores out. I haven't changed the mean. And then step 4. Step 4 is to add the new mean. So I take the scores where I've the next column over, and I add the mean new. And when I drag the mean and standard deviation, I should have a mean of 65 and a standard deviation of 5. Okay. Okay. And that is Belling curves. Now, the key thing here, and what people often forget, we often talk about what's the average. Well, the average was 79. Now the new average is 65. But the one piece of information that we tend to forget when we're looking at distributions is the standard deviation. So the standard deviation is actually pretty important. If I could keep the mean the same, but if I fiddle with the standard deviation, I increase the spread of the scores, because the standard deviation is a measure of dispersion. The greater the standard deviation, the greater the dispersion. Now, when I have a standard deviation of 5, I can look at this person here. That person had a grade of 45, and I bell the curve, I bell the marks, and that person ends up with a 52, which is a pass. And I go, oh, I don't know. I should have at least one failure. Now, I'll keep the mean of 65. And what no one ever really thinks about to ask about is the standard deviation. So if I change the standard deviation to, say, 6, that grade goes to a 50. So I got to take that to a 7. There. By spreading the scores out to a standard deviation of 7,